Iya Bu, dari berapa itu tadi?
Assalamualaikum. Desi, could you hear me? Boleh dengar saya tak, Desi? Assalamualaikum, Desi. Boleh dengar saya? Assalamualaikum.
Halo, Kak Noni.
Ya,
Maaf nih, si masuk lagi.
boleh dengar?
Masuk Kak dengar suaranya sih?
Dengar?
Oke ya,
Okey, suara Kak dengar tak?
tes.
Tes, suara Kak dengar tak, Desi? Boleh dengar
Kak.
suara?
Coba Kak, bercakap Kak.
Boleh dengar suara tak?
Oh, saya nggak dengar ya. Kenapa nggak dengar di sini ya?
Boleh dengar suara saya?
Intan, Mas Ayu, dengar suara Bu Noni, Dokter Noni?
Dengar Bu, suara Bu
Coba
Noni
share
dengar,
screen
suara
gitu,
Bu Desi
Dokter
juga
Noni.
dengar
Coba
Bu.
coba try share screen.
Boleh dengar tak? Okey, saya cuba share screen ya.
Dengar Ibu,
Intan
suara
boleh jadikan Dokter Noni sebagai ini
Sekejap saya
co-host
share.
kaliannya ya, co-host.
Okey, boleh nampak tak? Saya punya
Ini udah boleh nih.
sekejap. Boleh nampak?
Co-host ya Intan ya.
Sekarang boleh nampak tak?
Mana Ibu nggak dengar suaranya?
Boleh nampak tak? Boleh dengar suara, boleh nampak skrin? Skrinnya boleh nampak tak, Yesi? Mariza Intan, boleh nampak skrin saya tak?
Pak, suara juga terdengar.
Skrin nampak ya yang saya share?
Iya, nampak.
Terima kasih.
Tes, Intan, coba reply Intan.
Halo Ibu, suaranya masuk?
Ya, gimana itu? Udah nggak?
Halo Ibu,
Tes Intan, tes. Halo, Intan, balas Intan.
Iya, Ibu, suaranya masuk. Tapi
Alhamdulillah.
delay, Bu, di Intan.
Nggak apa-apa. Oke, oke. Ibu udah dengar, yang penting. Makasih. Thank you, Mas Ayu.
Yesi boleh dengar suara Kak? Boleh dengar Yesi?
Hmm.
Bu Yesi, sekarang ada suaranya nggak, Bu Intan?
Kedengaran, Tan? Bentar.
insentif publikasi ini yang ada.
Pak Slamet masih mute. Halo, Pak Slamet. Masih mute.
Pelatih
Ya,
kecil.
Bu.
Oh. Ini Dokter Noni dah join juga nih, Pak.
Oh, ya. Assalamualaikum, Dr. Noni.
Ya,
Dan juga Pak Karisma ini sama Pak Kaprodi TI ya.
kabar Pak Selamat.
Alhamdulillah baik. Apa kabar, Dr. Noni?
Alhamdulillah sehat.
Terima kasih ini sudah berkenan untuk bagi kuliah hari ini.
Ya, insyaAllah saya cuba. InsyaAllah kita sama-sama.
Mahasiswa belum pada gabung kok ini. Saya WA anak-anak dulu.
Pak Karisma gimana suaranya? Tes suara dulu, Pak. Pak Karisma.
Oke,
Oh iya
Assalamualaikum.
udah ya, Pak ya.
Nah, biasa. Assalamualaikum Pak Slamet, Prof. Noraini, dan Dr. Siti.
Ya, Waalaikumsalam. Kabar Pak Karisma?
Oke, sehat, alhamdulillah.
Alhamdulillah.
Ada 3 kategori. Itu dari rektor, bupati, sama gubernur.
Nah, iya, Pak Slamet.
Ya.
Dokter Siti Nuraini sama Pak Karisma. Kita mulakan saja ya, Pak ya.
Ya, mulai aja, Bu.
Baik, silakan.
Oke. Baiklah, silakan Mbak Intan sebagai MC, dipersilakan Mbak Intan.
Jelas. Tidak sih. Arab ya?
Kelas modern.
Sambal kuy. Sambal bapak nih buri. Your Excellency, the keynote speaker, Associate Professor Dr. Siti Nuraini binti Sulaiman from University. Your Excellency, the keynote speaker, Associate Professor Dr. Siti Nuraini binti Sulaiman from University Teknologi Mara, and Dr. Siti Nurul Akmariah Mohkanafiah from University Malaysia Perlis. Your Excellency, the Dean of Faculty of Engineering, Universitas Muhammadiyah Yogyakarta, Associate Professor Dr. Aris Widyo Nugroho. Your Excellency, the Head of Department of Electrical Engineering, Universitas Muhammadiyah Yogyakarta, Dr. Karisma Trinanda Putra. Your Excellency, the Head of Department of Information Technology, Universitas Muhammadiyah Yogyakarta, Dr. Cahya Damarjati. The Honorable all faculty members of the engineering and all participants of webinar expert lecture series on artificial intelligence. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
First of all, praise be to Allah Subhanahu wa Ta'ala, who has given us His mercy and blessing, so we can meet in this room today in healthy condition and attend the webinar expert lecture series on artificial intelligence at Universitas Muhammadiyah Yogyakarta. This webinar represents two subjects: computer vision in information technology department and image processing in electrical engineering department. Secondly, salawat and salam may always be present to our Prophet Muhammad Sallallahu Alaihi Wasallam, who has brought us from darkness to the lightness. Ladies and gentlemen, on this wonderful day, please allow me to start our agenda today by reciting Bismillah together. Bismillahirrahmanirrahim. The second agenda is a welcoming speech from the Dean of Faculty of Engineering, Universitas Muhammadiyah Yogyakarta, represented by Dr. Karisma Trinanda Putra. The time is yours.
Okay, Bismillahirrahmanirrahim. The Honorable Associate Professor Insinyur T.S. Dr. Siti Nuraini binti Sulaiman, the Honorable T.S. Dr. Siti Akmariah Mohkanafiah, the Honorable Dr. Yesi Jusman, Vice Dean, Faculty of Engineering, UMY, and the Honorable Bapak Slamet Riyadi, PhD. And then, ladies and gentlemen, my students, Assalamualaikum warahmatullahi wabarakatuh. A warm welcome to the expert lecture series on artificial intelligence, AI. It is with great pleasure and excitement that we gather here today to embark on a journey into the boundless realm of AI innovation and discovery. In this distinguished lecture series, we are privileged to host some of the brightest mind and visionary thinker in the field of artificial intelligence. And also for international exposure, this exposure is essential, especially for our students from electrical engineering and also from information technology in today's interconnected world. It offered them a valuable opportunity to broaden their horizon and also gain a global perspective. And also you can learn from other researchers from Malaysia. And I think it is very important for us to collaborate, to provide team teaching, and also give our students more benefits, especially in terms of international exposure. And thank you for joining us in this pursuit of knowledge and insight. On behalf of Mr. Aris Widyonugroho, as Dean of Faculty of Engineering, I would like to say thank you very much. Please join us in extending a warm welcome to Dr. Siti Noraini and Dr. Siti Akmaria. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Karisma Trinanda Putra, for the speech. For documentation purpose, we will take some pictures. And to all, please open your camera and I will count. One, two, three. Nah, itu lagi pagi. One, two, three. Thank you for your attention. Ladies and gentlemen, now we arrive at the core of the webinar that speaks of our two keynote speakers. It will be moderated by Associate Professor Dr. Slamet Riyadi and Dr. Yesi Jusman. For moderator of the first session by Associate Professor Dr. Slamet Riyadi. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Yang kami hormati Bapak Karisma, Pak Kaprodi yang mewakili Pak Dekan, terima kasih sudah membuka agenda kami. Profesor Dr. Noni, ya, kemudian Dr. Siti Nurul, sebenarnya. Mohon maaf. Ya, baik, kita akan langsung masuk pada sesi yang pertama. Sesi ini sebetulnya adalah bagian dari salah satu materi perkuliahan kita. Kalau di teknologi informasi itu ada mata kuliah computer vision, yang salah satu materinya adalah tentang object classification. Kemudian kita akan belajar satu algoritma, satu metode yang populer pada saat ini yaitu deep learning, sehingga memang kita khususkan untuk objek classification yang akan kita pelajari adalah object classification using deep learning. Nah, Profesor Nur Aini ini, Profesor Noni ini beliaunya adalah dari UCT Teknologi UITM, UCT Teknologi Mara ya, dari Malaysia, dan beliau sangat pakar di dalam bidang classification. Kalau kalian nanti search di Google begitu, nama beliau nanti akan muncul banyak sekali ya, sederet panjang artikel ilmiah bidang klasifikasi. Nah, khususnya adalah tentang juga deep learning. Beliau banyak sekali paper di bidang itu, sehingga nanti tolong mahasiswa semuanya, baik yang dari TI maupun dari TE, silahkan saja nanti betul-betul diperhatikan materi dari beliau. Kalau untuk dari TI, nanti sekali lagi saya ingatkan bahwa keluaran dari kuliah kita itu adalah berupa proyek yang menjadi artikel ilmiah, ya, bisa artikel ilmiah. Maka nanti klasifikasi dengan menggunakan deep learning ini adalah satu topik yang sangat menarik sekali untuk bisa kalian explore lebih jauh tentang topik tersebut, gitu. Sehingga nanti tolong Mas Mbak semuanya, adik-adik, baik yang dari elektro maupun TI, bisa mencermati dengan sebaik-baiknya. Langsung saja kita mohonkan kepada Profesor Noni untuk menyampaikan materi pada siang hari ini. Silakan Prof. Noni.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrofil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. Allahumma shalli ala sayyidina Muhammad wa ala sayyidina Muhammad. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Terima kasih Bapak Selamat atas sedikit aluan, terlalu besar aluannya. To start, without further ado, I would like to start my lecture today. As mentioned by Bapak Selamat, so today my lecture will be object classification using the deep learning. Before we start, hello everyone. Good afternoon.
Hello, good afternoon.
Prof.
Welcome today on my lecture. The topic is object classification using deep learning. Whether you are an undergraduate student or a student who is the postgraduate student, student taking your first step into the world of artificial intelligence. And for the postgraduate student, you will be diving deeper into this fascinating field. I'm thrilled to have you with me today. In the next maybe 1.5 hours, we will embark on an exciting journey into the computer vision and the incredible capabilities that deep learning can offer us. We will explore how the deep learning can help computer recognize and categorize objects, a fundamental skill with countless real-world applications. But before we jump into the detail, let us start with our title slide, which is the object classification using deep learning. And after that, let's have a glimpse what I will prepare for you. Today's journey through the object classification using deep learning, I will promise both enlightening and exciting, especially for our students, whether you are just starting your undergraduate studies or you are pursuing your advanced knowledge in this field. Here is the roadmap of what I've prepared for you. First, I will start with introduction. Okay, we will begin by understanding the core concept and why object classification matters in the world of artificial intelligence. Okay, next we will look at the classification concept. We will explore the very essence of supervised learning and how we teach computers to classify the object. This is a fundamental concept. And then we move to data collection. Okay, we will dig into the critical process of gathering the data and creating label dataset, which is the fuel that powers our algorithm. And then we jump into deep learnings and model. We will take a deep dive into a deep learning, discussing its architecture and the models that drive the innovation in object classification. And then I will share with you the model training, building on the fundamental foundation. We will explore the process of training of this model, helping them learning to recognize the object. Next, we move to performance evaluation. Okay, every good scientist needs a measuring stick. So we will look into how we evaluate the performance of our models in a real-world scenario. And then we try to look at the evaluation metric. We use the precision, recall, accuracy, and these are the matrices for success. We will demystify them and then understand their significance. And then we move into model evaluation, okay, with a graph of metrics. We will then evaluate a model performance on a test data set and discuss the strategies for improvement. And I will give a summary as we near to the end of our journey. Okay, we will summarize the key takeaway and the broader implication of our exploration. And I will have, if I have a time, I will share with you some case study, and I will open with you for question and answer. Okay, so that is the outline of my presentation today. So this is the roadmap in mind. Let us set up on this learning adventure into the world of object classification using the deep learning. Okay, today we are here to explore the topic that both fascinating and relevant, especially in the context of today's technology-driven world. Object classification is not just a buzzword. It is a fundamental building block of computer vision and AI system. It's what allows the mission to see and understand their surrounding, opening doors to innovation in self-driving cars, healthcare, robotics, and many more. So we know that the object classification have been used in many other fields. So our goals for today are clear. First, we want to understand what is the object classification, making it approachable and understandable. Second, we will dive into the world of deep learning, exploring its architecture and model, which have played an important role in advancing this field. So whether you are taking your first step in AI or looking to deepen your knowledge, so let us get ready to be inspired by the possibility of object classification using this deep learning. Okay, so now let us dig deeper into the core concept that form the foundation of object classification using deep learning. First, we look at the definition of the object classification. Object classification is the process of teaching computer to recognize and categorize the object within images or data. It is like we teach a computer to distinguish between the cats and a dog in a photograph, or identifying handwriting digits in a scanned document. So the object classification in the context of computer vision is the task of teaching machine to recognize and categorize objects within images or data. It is the ability to answer a question like, maybe, is this a dog or a cat? Okay, or what is a digit that written in the image? So the object classification forms the basic of various applications from image tagging to medical diagnosis. So that is if we apply the object classification in the medical field. This is the ability to automatically categorize the object. It is the heart of many AI applications we encounter daily. The object detection versus the classification. Maybe some people may ask, what is the difference between classification and the detection? So before we move on, let's clarify the distinction between image recognition and object detection. The image classification, normally we send the whole image through a classifier. Maybe we use a deep learning as our classifier. So the image classification will send the whole image through the classifier without splitting the tag. Okay. Classifiers take into consideration the whole image, but don't tell us where is the tag that appear in the image. However, in the object detection, it is slightly more advanced, where it creates the bounding box around the classified object, mention that what is that object that has been detected. Okay, for example, here, it creates a bounding box and identify what is the object. It is cat, dog, and a dog. Okay. Next, okay, we move on the concept of supervised learning. Okay, so the concept of supervised learning is the driving force behind the object classification. The object classification is achieved primarily through a subfield of machine learning, which is known as supervised learning. In supervised learning, we provide our algorithm with a label dataset, meaning each example in our dataset has an associated ground truth label. For instance, if we are classifying an image of fruit, so each image would come with a label indicating whether it is a tomato, a carrot, or a bell pepper. Okay, so our model will use this label example to learn the pattern and make prediction. The supervised learning learns from this label example and make prediction on a new, which is the unlabeled data. Okay, this is important to teach a computer to recognize the pattern and make decision based on the pattern. Okay, to ensure that our model generalize well and perform accurately on a new unseen data, so we employ a crucial technique which is known as training and testing paradigm. Okay, so this involves we need to split our data into two parts. Okay, the training data set and the testing data set. The training data set is the portion of data set which is used to train our model. It is where our model learns to recognize the pattern and characterize associated with each object category, while the testing dataset is kept separate and is used to evaluate the model performance. So it helps us to determine how well the model generalized and how well the model learned the knowledge to make the accurate prediction on a new unseen data. So the training testing paradigm ensure that our model are not just memorizing the example that they have seen before, but are truly learning to recognize the object, setting the stage for a robust and reliable object classification. So as we move further on our exploration, so please keep in your mind that these are the fundamental concepts in deep learning and object classification, where they provide the groundwork for understanding the deep learning and its role in the object classification. Okay, next. As we transition into the deep learning and object classification, we encounter a fundamental truth, which is the data is the lifeblood of our model. Okay, the quality and quantity of data we use plays an important role in the success of our project. So let us underscore the importance of the high quality level dataset. In the context of object classification, a dataset consists of a vast collection of images or data points where each is associated with a specific label. So this label defines the object category to which data points belong. For instance, in image classification, each data image should be tagged with its corresponding object category, such as it must be tagged into the cat, dog, or a car. So a high quality level dataset serves as the foundation for teaching our model to recognize the object. The accuracy and the richness of this level will directly impact the accuracy and generalization capabilities of our models. They enable the model to learn the distinguishing features and characteristics of each object category. An inaccurate or incomplete data or incomplete label will lead to a bias and errors in our model, where it affecting their real-world performance. Therefore, we need to be meticulous. Meticulous attention to data labeling is very critical. Nowadays, we understand that the importance of a high quality label dataset. So let us explore where we can find such dataset. So nowadays we have the public data set, where there are numerous publicly available data set tailored to different object classification tasks. For example, the platform like Kaggle, UCI Machine Learning Repository, and ImageNet, they provide the access of a wealth level data for practice and research. Sometimes we may depend on the custom data collection. Okay, in some cases, you may need to create your own data. So to address the specific domain or application of depends on your requirements. So this involves we need to capture the image or data point and bear in mind that we need to be meticulously label them. Okay, maybe we also depends on the data provider. Okay, some organizations and curating the label data for a wide range application where this provider can offer the access to the high quality data set. And normally it is used in the commercial project. And sometimes we depends on the transfer learning. Okay, for a specific task, it is possible to leverage based on the pre-existing model trained on the extensive data set. Okay, we just need to fine-tune them for our particular case. Okay, fine-tune them for your own particular use case, and this normally can save considerable time and effort in data collection. All right, as we move forward, please remember that the data collection is a crucial step in object classification, and the quality and diversity of our data set are the integral to the success of our object classification model that we will develop next. Okay, so now we have explored the importance of data. So it is a time to introduce the force that powers up the object classification journeys, which is the deep learning. Okay, the deep learning has reshaped the landscape of artificial intelligence and computer vision, where it's opened up a new possibilities in recognizing and categorizing the object. What is the deep learning? Okay, deep learning is actually the subfield in machine learning, where it is a paradigm that revolves around the use of deep neural network. Okay, what makes it so powerful is its ability to automatically learn the pattern and do the representation, the data representation, okay, making it ideally suited for the task like this object classification. So deep neural network are composed of multi-layers, okay, and allowing them to capture hierarchical features and abstract representation. The hierarchical features and abstract representation, this depth is what sets them apart from the traditional machine learning model. At the heart of deep learning are a deep neural network, okay, where these neural networks are inspired by the structure of human brain, where it consisting the interconnected layers of artificial neuron and also known as perceptron. So these neurons are computationally units that process and transform the data. So now let us take a look on the architecture of a deep neural network, which form the backbone of a deep learning and enable us to tackle the complex tasks like the object classification. In typical deep neural network, we organize this layer into three main components, which is we have the input layer, the hidden layer, and the output layer. Okay, the input layer, this is where our data enters the neural network. So each neuron in the input layer will represent an image. For instance, in image classification, each neuron may correspond to the pixels intensity color. While the hidden layer, okay, is the layer between the input layer and the output layer. We can have more hidden layers, okay, where these layers is where the magic happens. Okay, each neuron in the hidden layer will process the input data using a weighted sum and applies the activation function, and this process will enables the network to learn pattern and representation from the data. The depth of this layer gives the name to the deep neural network. Okay, that's why we have the name deep neural network. Okay, or deep learning. All right, the final layer, which is the output layer. Okay, the final layer known as the output layer, where it produces the network prediction or the classification. Okay, the number of neurons in this layer correspond to number of possible output categories that we may set beforehand. For instance, if we are classifying object into
Selain menggunakan PHP, menggunakan apa lagi?
Is it okay over there?
Halo. Cek, tolong itu ada yang mic-nya ini.
Alright. So, for
Oke,
instance,
lanjut Prof.
okay, so I can proceed. Okay, the final layer, okay, I repeat, the final layer and the output layer, okay, known as the output layer, produce the network's prediction or classification, where the numbers of neurons here is corresponding to the output categories that we have set beforehand. Okay, for instance, if we are classifying object into three categories, which is cat, dogs, and car, so we would have 3 neurons at the output layer. Okay, so now where the real power of the deep learning comes into play, where the deep learning models employs a technique which is called deep backpropagation. Okay, during the training, the model makes prediction based on its current parameter, which is we have adjusted the weight and the bias, and compare this prediction to the actual level, and then calculate the difference between them. So the backpropagation then propagates this error backward through the network and adjusting the model's parameter in a way that we need to minimize the error. Okay, so in this iterative process of fine-tuning the model's parameter, that's allowed the deep neural network to learn a complex relationship and the representation within the data. Okay, and then it ultimately leading to accurate object classification. where this deep learning model harness the power of backpropagation to iteratively adjust the model parameter, which is the weight and the bias during the training, and minimizing the difference between the predicted and the actual level. Okay, in the context of object classification, convolutional neural network, okay, CNN, have taken the spotlight. This is the most popular deep learning that used in the object classification. Okay, so the CNN are designed to work with a grid-like data, such as the image, okay, where they excel at automatically extracting relevant features from images, making them a go-to choice for object classification tasks. So the deep learning algorithm for image processing and image classification, convolutional neural network are the best and the best suited for image processing and image classification problem. As the CNN, the convolution operation in the CNN operation allow the processing of the image with the help of a different filters function. Okay, some of the most popular CNN used are like AlexNet, VGGNet, GoogleNet, ResNet, and many more. Okay, and beyond the CNN, there are various other deep learning architecture. So each with its own strength. Okay, the other model, which is include the recurrent neural network, RNN. Okay, this is normally used for sequential data, transformers for natural language processing, and many more. Okay, as we continue, we will explore the fascinating world of CNN in a greater detail, as they form the backbone of many object classification applications. So be prepared to be amazed by the capabilities of this deep learning and its role in recognizing recognizing the object with high precision. Okay, so now we have laid the foundation by understanding the architecture of deep neural network and the significance of data. So let us dive into a critical phase of our journey, which is we need to train the deep learning model. Okay, so training a deep learning model is similar to teaching it how to make sense of the world. The process begins with model initialization, where it starts with random weights and bias. We guide the model learning through a supervised process using the label data. So each piece of label data in our training set consists of an input. Okay, for instance, we have an image, and then the corresponding correct output, where it is called, normally, the researcher call it as the ground truth, okay, which is the object that categorizes the label. Okay, during the training, the model will make prediction based on its current parameter, which is the weight and bias that initialized in the earlier stage. Okay, so these predictions are then compared to the actual level. The goal is to minimize the difference between the prediction and the true level, which is the actual data. So the process of adjusting the model parameter to minimize this difference is where the magic happens, which is called the optimization. Okay, this optimization is achieved through a technique like the gradient descent. Okay, for example, we use the gradient descent. Okay, so the model will iteratively tweak its parameter to make better prediction, moving it closer and closer to the correct answer. Okay, as the model goes through the multiple iteration, or we call it epoch. Okay, sometimes the researcher call it epoch. It's gradually improve its ability to recognize the pattern and features in the data. So becoming it increasingly accurate in its prediction. Okay, so label data is the fuel that powers the training process. Each label example that we provide to the model with an opportunity to learn and adapt. Okay, it's like having a good teacher guiding the model by saying that this is what the correct and this is what is not correct. Okay, so the accuracy and the quality of this label directly impact the model learning. The accurate label help the model to distinguish between the different object categories, while incorrect label can lead to a confusion and a bias. Okay, so the power of deep learning lies in its ability to automatically learn and adjust its internal representation based on the pattern it observed in the label data. Okay, so this adaptability will allow the deep learning model to excel in a task like object classification, where the pattern and the features plays a central role. Okay, as we move in our journey, remember that training a deep learning model is a complex yet fascinating process. Okay, it is where the model evolves from a blank slate to a sophisticated tool which is capable of making the intelligent decision. So this is all thanks to the guidance of the label data that we provide to the our model and the optimization technique that we use to make the our model intelligent. Okay, so as we progress through the object classification using this deep learning, so we have arrived at a significance point where the evaluation of our model performance. Okay, this is the most important. Sorry. Okay, so understanding how well our model are doing is essential for making informed decision and ensuring their real-world application is applicable. Okay, so evaluating the model performance is not just a formality. Okay, it is a crucial step in deep learning process. Okay, here is the why it is matter. Okay, why it is matter. First is the real world applicability. So we build our model. Okay, this model that we build, we need an accurate model. Okay, so we build this model to make an accurate prediction and classification in real world scenario. Okay, evaluating their performance help us gauge their readiness for deployment. And then, why it is matters? For comparison. Okay, performance evaluation allow us to compare different model architecture or hyperparameter that we use to determine which one works better for our specific task. Okay, it is why we need to do the performance evaluation is for comparison purposes. Okay, and then why it is important of evaluating the model performance? It is because we need to do the model improvement. Okay, by identifying areas where our model falls short, we can refine them and enhance their capabilities. Okay, continuous improvement is essential for staying in the forefront in this world of rapid technology nowadays. Okay, and the final reason why we need to have to evaluate our model is to ensure that our model performs fairly and without bias. It is very crucial. Okay, it is based on ethical consideration. Okay, especially when involved in application like healthcare, finance, and criminal justice. Okay, to assess how well our model are performing, okay, we are rely on evaluation matrices. Okay, so these matrices, okay, provide quantifiability measures of their accuracy, precision, recall, and overall effectiveness. Okay, let us briefly introduce. Let me introduce some key evaluation matrices. The first one is accuracy, where this matrix use the overall correctness of our model prediction, and it tells us the proportion of correctly classified example out of all example given. The precision tell us how many of the positive prediction predict how many of the positive prediction made by the model were actually correct. Okay, so it actually focuses on the quality of positive prediction. The recall is also known as sensitivity or true positive rate. Okay, measures the model's ability to correctly identify positive instances from all actual positive instances. The next matrices is F1 score. Okay, the F1 score is the harmonic means of precision and recall. Okay, where it provides a balanced view of both precision and recall, which is often important in object classification tasks. The next matrices is receiver operation characteristic curve and the area under curve, ROC and AUC. Okay, where these matrices are frequently used in binary classification tasks to evaluate the model's ability to distinguish between positive and negative classes. And finally, the confusion matrix. Okay, a confusion matrix provide details breakdown of true positive, true negative, false positive, and false negative, offering a deeper insight into our model that we have developed, the model performance. Okay, so as we venture further, we will explore these evaluation matrices in more detail and learn how to interpret and apply them effectively. Okay, remember, understanding the matrices will help us to gauge how well our model are performing and make informed the decision about their use and potential improvement. Okay, so now let's take a closer look at some common evaluation matrices. Okay, where these matrices act as our guiding compass, helping us navigating through the vast landscape of model performance and enabling us to make informed the decision about our deep learning model. Okay, first is the accuracy. Accuracy is perhaps the most intuitive metrics. Okay, it is measures the overall correctness of our model prediction. Okay, in simple terms, it tells us the proportion of correctly classified example out of all the example. While the accuracy is essential, it may not always be sufficient. Okay, especially when dealing with imbalanced or unbalanced data set. The next one is precision. Okay, the precision focuses on the quality of positive prediction. It tells us how many of the positive prediction made by the model. Okay, it tells us how many of the positive prediction made by the model were actually correct. Okay, in other words, it measures the ability of the model to avoid the false positive. Okay, for precision is particularly crucial in scenarios where the false positive can significant consequences. The next one is recall. Okay, recall, also known as a sensitivity or true positive rate, it measures the model's ability to correctly identify positive instances from all actual positive instances. Okay, it's normally answer the question of all these actual positive instances, how many that the model correctly identified. Okay, so recall is vital when we want to avoid missing positive cases. Okay, this is vital, very vital. Okay, so the next one is F1 score. Okay, F1 score is the harmonic means of precision and recall. Okay, so this matrix is especially useful when we need a single measure that consider both false positive and false negative. Okay, it is well suited for tasks where there is imbalance between classes that we have. Okay. The next one is ROC and AUC. Okay, receiver operating characteristic curve and area under the curve. Okay, so these matrices are commonly used in binary classification tasks where the ROC curve plot the trade-off between the true positive rate and the false positive rate at various thresholds. Okay, so while AUC quantifies the overall performance of the model in distinguishing between positive and the negative classes. Okay, a higher AUC will indicate a better performance model. Okay, and finally is the confusion matrix. Okay, while not a single matrix, the confusion matrix is a valuable tool, a detail where it provides a detailed breakdown of true positive, true negative, false positive, and false negative. It's a great starting point for a deeper analysis of our model behavior. Okay, so these evaluation metrics are not just a number, they are our compass in evaluating the effectiveness of our model. Okay, accuracy, precision, recall, and F1 score help us understand the model correctness, the quality of positive prediction, ability to capture all positive instances, and overall balance between the precision and recall. While the ROC, curve, and AUC provide an insight into the model's ability to distinguish between classes, particularly in binary classification tasks. And the final, the confusion matrix offer a granular view of the model performance, helping us identify where it excels and where it may need improvement later. Okay, by comprehending and leveraging these matrices, we can make informed decisions about our models. We can fine-tune them for optimal performance, and we can ensure the reliability of our model in real-world application. Okay, they are our allies in the quest for accurate and trustworthy object classification using the deep learning. Okay, so now let's move from theory to practice and witness the fruit of our labor. Okay, we have been discussing the intricacies of deep learning, the data, the evaluation matrices. So, but it's time to see how all these components come together in the real world. Okay, so to assess our models through capabilities, we conduct rigorous evaluation on a separate dataset known as testing dataset. Okay, so this dataset contains examples that the model never seen before during the training. Okay, where this simulating the real world scenario, but it encounters a new unseen data. Okay. The result of evaluation provide us with a clear picture of how well our model performs when confronted with the challenges outside the training data. Okay, so in our model evaluation, we focus on several key aspects. Okay, it is now we are at the stage of testing, not at training stage. Okay, at the testing stage, our model evaluation focus on several aspects, which is accuracy, precision, recall, F1 score, ROC, as well as the confusion matrix. Okay, so in accuracy, we calculate the overall accuracy of our model on the test dataset. Okay, now this metric provide a general sense of how well our model is performing, but should be considered alongside these matrices for a more comprehensive evaluation. So we use the precision. Okay, we examine the precision, recall, and F1 score to gain an insight, okay, into our model ability to make the correct positive prediction, capture all positive instances, and strike a balance between precision and recall. Okay, for binary classification, we use the ROC and AUC. Okay, we analyze the ROC curve and AUC to assess the model ability to distinguish between positive and negative classes at the threshold. Okay. So by these matrices, okay, we provide a comprehensive view of our model performance, offering quantitative evidence of its capability. For a more depth understanding of our model performance, we can showcase an example of what lies in the confusion matrix. Okay, for example, an example of confusion matrix or the performance graph. Okay, in the confusion matrix, we have 4 key components, which is true positive, true negative, false positive, and false negative. Okay, so this visual representation help us identify where our model excel and where it may need further refinement. It's particularly useful for understanding the model's behavior in terms of classifying positive and negative cases. While the performance graph, like ROC curve, it provides the dynamic view of our model's performance across various threshold or the scenario. In the case of ROC curve, okay, they show the trade-off between the true positive rate between the and the false positive rate at different decision threshold. Okay, a higher AUC will indicate a better performing model. Okay, this visual offers a snapshot of how our model behaves in different situations. So helping us make informed decision about its readiness for deployment, or does it need further fine-tune. Okay, by examining these results, we move beyond theory and into practical validation. Okay, the model evaluation is where our model are put to the test. Okay, and the evidence we gather here inform us about their real-world applicability and areas where they may require improvement. Right. So, my dear student, okay, as we draw the exploration to a close, okay, let's take a moment to recap the key insight we have gained and recognize the immense significance of deep learning in the subject of object classification. Okay, so I will summarize. We begin with understanding the fundamental of object classification and the supervised learning paradigm, which serve as the foundation of our approach. And then we have looked into the data collection, where the data collection emerged as a critical step, highlighting the importance of the high quality level dataset in training our model effectively. We explore into the world of deep learning and its architecture, discovering how the deep neural network intricate the patterns from the data. And then the model training unveil the magic of optimization, where the model iteratively adjusts the parameter using the level data to make the accurate prediction. And then the performance evaluation brought to the light the necessity of assessing our model effectively, with a focus on the key matrices like accuracy, precision, recall, and F1 score. Okay, we have ventured further into model evaluation, where the most important point for something, which is the moment of the truth, is the testing dataset. We witness the tangible result of our effort on the test dataset. The significance of deep learning in object classification with deep neural network has revolutionized the field of object classification. So it has brought us closer to create machine that can see, can understand, and categorize the world as we do. Okay, the ability to automatically extract features from data, learn complex patterns, and adapt to different tasks has made deep learning model such as CNN, okay, such as the CNN as the go-to choice for our object classification. Okay, the deep learning is not just a technology, it is a paradigm shift. Okay, it's empower us to solve a real world problems that were previously considered too complex or computationally extensive. Whether it is identifying disease in medical images, recognizing faces in photograph, or classifying objects in autonomous vehicle, the deep learning has found application in nearly every industry, shaping the future of the technology and the innovation. Okay, in closing, the object classification using deep learning has not only provided us with knowledge, but has also opened door to endless possibility. As students, whether the undergraduate or the postgraduate level, you stand at the forefront of a field that continues to evolve and redefine what is possible. Okay, deep learning is your gateway to make a profound impact on the world, and I encourage you to explore deep further. Okay, so thank you for joining me. Okay, and I look forward to see the incredible continuous contribution you will make in the world of object classification and beyond. Okay, before that, maybe I would like to share something what in my research team have done. This is the completed and my ongoing postgraduate research have done. Okay, these are my students' work. Okay, where they also ventures. Okay, I would like to share with you one case study where they use the deep neural network for classification. Do I have more time? Can I proceed with this case study? Boleh ke, Bu Yesi?
Ya, boleh dokter.
Okay, so this is the
Boleh sangat.
my students' work. Okay, where they use the object classification. Okay, the work done by my PhD student, Dayang Suhaida. Okay, so it involves the classifying. Okay, the disease is I explored in the medical image diagnosis or medical diagnosis system. Okay, so in this case, we focus on the cardiac disease. Okay, they use the delayed enhancement cardiac magnetic resonance imaging, where this is the images that the data that we collected from this from the hospital. Okay, right. So medically, the doctor need to classify in this so at this point, this is our heart in MRI. So medical doctor, they were interested to classify this image into several parts, which is known as upper vessel, the left ventricle image, the upper vessel, the left ventricle, and lower apical. Okay, so we use the deep learning, okay, to classify upper vessel, left ventricle, this is the most critical part. Okay, that the most interesting, the ROI part that the radiologists need to see, only this part. But while they processing the DECMR, the images produced is the whole part. Okay, we need to eliminate the upper vessel and the lower apical. Okay, so in this case, while assessing the patient, the LV cardiac segment, okay, only the slices with the image of in this part, the LV cardiac segment is used by the radiologist. The rest are neglected. So we use this. So we use the CNN to classify, okay, the object. Okay, so this is the objective, to develop the left ventricle and non-left ventricle classification model using the pre-trained CNN architecture. They leverage, my student leverage the use of the pre-trained CNN. Okay, so the next is to analyze the role played by the geometric transformation technique in optimizing the performance of the pre-trained model that given the task. Okay, so this is the methodology. We need to do the data preparation. Okay, remember just now we need to label the data, unlabel data. We need to give the input to the our deep learning. Okay, and of course, when we dealing with these medical images, we need to comply with the ethics. We have to apply for ethical approval first. Okay, so we use, my student use the MATLAB. Okay, they adjust the parameter of the pre-train, and this is all the training scenario that they have done. Okay, okay, so this is the data. Okay, they use the augmentation data because images, the medical images is very limited. Okay, the training data set that we obtained before augmentation, we only have 240, and we split into the testing data set, only we have 60 images. So we apply the data augmentation, okay, making that we have the training data set 1,200 images, and the testing data set is 300 images. So these are the results that they have analyzed. Okay, as I mentioned, they use the, in this case, my student used the accuracy. Okay, remember just now we have other matrices that can be used to see the performance of our model. We can use accuracy, precision, recall, and for this case, my student used the accuracy. Okay, to see the performance for comparison purposes. Okay, which model perform better? Okay, so when they compare, okay, the pre-trained, they use the GoNet, SqueezeNet, ResNet, and ShuffleNet. Okay, these are the CNN models. Okay, so they compare based on the performance. ResNet has the highest accuracy. Right? My student also use the F1 score. Okay, the overall F1 score, the ResNet shows the highest score. Right? This is the overall performance of these classes. They compare before augmentation and after augmentation. They nak tengok, they want to see whether the augmentation process help the model that we have developed, help the performance, increase the performance. This is the one of the optimization process that we use in fine-tuning our model. Okay, right. So these are the result. Okay, the conclusion. My student, okay, they see that okay, the difference between the pre-trained and the private, when they use the pre-trained CNN model, they can see that ResNet architecture achieved the highest performance with the average accuracy of 97.78 and F1 score of 97%. The other example of my other student is also my PhD student. This one is focusing on the still on the object classification, but now they focus on the digital breast tomosynthesis image. The disease is breast cancer. Okay, so my student, this student, use the CNN, which is she constructed from scratch. Okay, so I will skip the introduction. Let us focus on the method, how they fine-tune their deep learning, okay, optimize it so that it can achieve whatever the objective stated. Okay, the objective is they need to develop the blur detection. Okay, you need to classify from the images, the DBT images, which one is blur and which one is non-blur. Okay, because in DBT images, normally the image that we obtain is sometimes blur. It quite blur because it degrades by the blurry artifact. Okay, so we need to use the CNN to classify which one is blur and which one is non-blur. Okay, so that the medical doctor will only focus on the non-blur image. Okay. All right. So for this student, she used the data, okay, the level data obtained from the website. Okay, this is the public data. Okay, okay, remember just now I mentioned the data that we collected may come from the public data set, or we acquire in for our private use. Okay, so in this case, my student obtained the data from the public data set, open source clinical trial images. Okay, so this image is in the form of DICOM. Okay, in the fine tuning, how she optimized the her deep learning, they use the optimizer, different optimizer, which is SGDM, ADAM, and RMS-PROB. Okay, so this is the CNN that she used. CNN she built from scratch, where the CNN that she proposed has the input layer, middle layer, and final layer. Okay, and then the performance, okay, we need to evaluate our image that we produce, our system that we produce. Okay, she used the accuracy and AUC, okay, to compare between the architecture that she used just now. Okay, as well as she also used the confusion matrix, okay, to look deeper into the architecture. Okay, so this is the example of how we can use the deep learning. Okay, it starts from the data, and then we optimize, and then we have to evaluate the performance. Okay, so I think I would like to open for the floor to ask a question. Okay, so feel free to ask any question. Okay, so I pass back to the moderator. Thank you very much.
Intan. Selamat. Halo, Bapak Selamat. Oke, baik. Oke, Terima kasih Dr. Noni telah memberikan banyak apa ya study from daripada yang Dokter dah sampaikan tadi, ada banyak knowledge yang sudah kita serap dan juga contoh-contoh riset ya, case research yang sudah dilakukan oleh student Prof. Siti Nuraini. Oke, tadi saya diminta Bapak Slamet ya, kalau Pak Slamet ada keluar sebentar, nanti kalau tidak ada respon, jadi saya bantu gitu. Oke, baik. Terima kasih Prof. Siti Nuraini. Kepada yang mendengarkan ya, adik-adik mahasiswa semua, apakah ada yang bertanya dari mahasiswa TI dan TE juga boleh bertanya, semua boleh bertanya yang hadir di sini, silakan. Oke, tadi kita lihat. Nanti raise hand aja ya sambil saya berbicara. Tadi Dr. Prof. Siti Nuraini sudah membentangkan dari teori dan juga case study untuk breast cancer dan juga untuk blur image. Nah, dari pemakaian dari deep learning ini sangat powerful untuk dapat melihat secara cepat menggunakan komputer dan juga dapat mengekstrak weight yang dapat digunakan nanti sebagai parameter yang sudah di training, yang dipelajari oleh sistem, nanti bisa diimplement kepada problem-problem yang ada dalam kehidupan sehari-hari. Tadi ada contohnya in medical ya, bisa juga dengan di bagian selain medical juga banyak part yang boleh diimplementkan klasifikasi dengan menggunakan deep learning ini. Ya, ada juga contoh dengan di civil engineering juga dapat digunakan, dan juga security system juga boleh digunakan. Oke, tak ada yang bertanya ya, saya tanya, kalau begitu saya sangat curious dengan riset Prof. Siti Nuraini tadi. Untuk data yang tadi itu CT scan image atau MRI ya, Prof? Yang tadi yang ada upper level upper ada bagian button.
Itu disease berkenaan dengan jantung, masalah jantung kita.
Oh, jantung. Itu berarti pakai
jantung. Jadi dekat sini kita ada satu modalities for cardiac. Okay, it is called the cardiac magnetic resonance image, MRI lah. Okay, but
MRI,
but it's specifically for cardiac, so it is called the cardiac magnetic resonance image.
Oh gitu.
MRI, ya.
Jadi khusus untuk bagian jantung.
Ya, betul.
Oke. Nah, canggih sekali ya, dapat melihat bagian bawah, bagian atas, dan juga ada ya, Prof tadi, classes tempat locationnya tadi. Boleh dijelaskan kenapa menggunakan three position untuk melihat mendapatkan image ada 3 classes tadi ya?
Oke. Sekejap mungkin saya boleh sharekan semula. Okay. Alright. So untuk cardiac image, okay, yang dipanggil ini DE is for delay, dia akan menggunakan satu kita panggil contrast agent untuk melihat kepada segmen-segmen di dalam cardiac ini, okay, through the MRI image itu. Okay, MRI yang fokus kepada cardiac is called the CMR, okay, cardiac magnetic resonance image. Okay, so apabila the patient, okay, the patient pass through the MRI, ini macam machine MRI juga. Okay, so apabila patient pass through the MRI punya machine, okay, so dia akan concept of MRI, dia akan capture the image slice by slice. Okay, slice by slice depending on berapa yang the thickness yang ditentukan oleh radiologist tu, okay, untuk didapatkan data. So that is why angle yang kita ambil dalam MRI ini is short axis. Okay, dalam MRI dia ada banyak kita panggil banyak channel lah, lebih kurang banyak channel lah. Short axis. So bila kita ambil angle the short axis, dia akan slicekan berdasarkan apa vessel ni adalah bahagian atas jantung. Kita cuba bayangkan seperti buah mangga, kan? Sebiji buah mangga, sebiji mango, dia akan tengok portion slice by slice daripada atas sehinggalah ke bahagian bawah. So itu the normal routine when the patient go through the MRI machine. The normal routine dia akan the image that been captured akan from the upper level sampailah ke bawah. But in this disease, okay, untuk masalah kardiovaskular ni selalunya dia exist dekat bahagian low ventricle, left ventricle. Okay, left ventricle dia cuma akan boleh nampak kalau bahagian atas tu macam tak berapa boleh kita nak nampak. That's why most of radiologists they only focus on the middle one. Okay, so dia akan buang bahagian atas dan juga dia akan buang bahagian yang penghujungnya di bawah. Itu Ibu Yesi.
Oke, sebab yang ini ya Dr. Prof. Siti, sebab di bahagian yang tengah itulah yang akan dicurigai adanya abnormality ya?
Ya, betul.
Oke, sebab itu dia hapus. Ya, mahasiswa dapat ya. Mahasiswa dapat. Kenapa tadi Prof. Siti Nurani ya daripada riset mahasiswanya itu membagi menjadi 3 region gitu ya. Ada region atas, region bawah. Nah, untuk menggunakan MRI itu semua slice-nya akan di capture gitu ya. Nah, namun kita selected untuk bagian yang tengah karena bagian tengah itu lah tempat dicurigai adanya keabnormalitian gitu. Jadi ibaratnya Tino ini, sebab itu kita fokus pada slice yang pertengahan. Beberapa image yang di capture dengan pada posisi pertengahan gitu ya. Oke, terima kasih Prof. Siti Nuraini atas sharing knowledge-nya dan juga langsung kepada cases sehingga kita dapat improve ya kepada student-student yang ada. Nanti Bapak Slamet, kalau kelasnya Bapak Slamet juga kelasnya saya nanti di bagian image processing kita akan bermuara kepada project ya. Jadi ini adalah salah satu keilmuan ataupun sharing yang langsung pada kasus sehingga nanti kita udah dapat melihat ya langsung dan juga dapat mempraktikkan nanti untuk proyeknya ke depan. Oke, tadi Dr. Siti Nurani pun sudah menjabarkan ya untuk deep learning itu kita menggunakan beberapa kategori-kategori tertentu untuk optimization tekniknya, ada Adam dan lain-lain. Nah, dan juga dari beberapa parameter yang perlu kita set up nanti di MATLAB ya, maka nanti bisa kita run dan dapat menghasilkan otak lah ibaratnya ya, otak ataupun wake learning ya, wake untuk dapat kita implement kepada sebuah sistem otomatis yang akan kita improve. Oke, terima kasih Prof. Siti Nuraini atas sharingnya yang sangat berharga sekali ya. Saya haturkan terima kasih untuk sesi ini kepada Prof. Siti Nuraini dan salam untuk semua kolega yang ada di UITM UITM Pineng.
Okay, terima kasih PAC kerana giving me this opportunity. I hope that my lecture will benefit the student, okay, to get some insight, okay, on object classification, okay, using this deep learning. Okay, Bu Yesi, boleh saya for the next lecture?
Boleh. Ini ada lecture series nih, Prof Siti. Nanti kita akan ada lagi karena kita dalam satu SEM untuk Prof Siti di mata kuliah Computer Vision bersama Bapak Slamet Riyadi ya, dan juga satu lagi Dr. Siti Nuraini dalam mata kuliah saya kita join join lecture gitu, di mata kuliah image processing. Nah, sesungguhnya Prof Siti Nuraini juga expert dalam image processing ya, tapi kita berbagi peran supaya semua dapat kesempatan ya Prof Siti ya. Oke, terima kasih sekali lagi kepada Prof Siti Nuraini, dan untuk the next topic ya, kita akan lanjutkan ke MC untuk dapat melanjutkan ke sesi yang kedua.
For moderator of the second session by Dr. Yesi Jusman, the time is yours.
Baik ya, berjumpa lagi dengan saya. Keep dalam channel ini ya, mahasiswa semua yang dalam mata kuliah Computer Vision, yang Informatical Engineering, dan juga dalam mata kuliah Image Processing ya, dalam Prodi Teknik Elektro. Oke, now for the next agenda adalah kita akan sharing tentang image processing, yang mana tadi juga sudah sangat dibahas oleh Prof Siti Nuraini ya, tentang deep learning, yang mana input daripada deep learning yang dijelaskan oleh Prof Siti Nuraini dan juga yang riset beliau itu adalah citra digital ya. Dalam bahasa Indonesianya citra, kalau dalam bahasa Inggrisnya tentu image ya. Nah, digital image, nah pada saat sekarang ini, kenapa AI ya, AI, Artificial Intelligence, begitu sangat menggemparkan dunia ya, dengan implementation semua AI, dalam semua kehidupan manusia dapat dimanfaatkan AI, karena dalam kegiatan manusia, dalam permasalahan yang dihadapi oleh manusia sehari-hari, itu seringnya adalah mengkategorikan ya, mengkategorikan sesuatu menjadi beberapa level, sehingga apabila manusia yang melakukannya, kategori mensortir manually, itu akan mengakibatkan waste time. Nah, contohnya kalau dalam image, menggunakan citra, dalam dunia kedokteran pun ya, sekarang improve dari alat-alat kedokteran itu sudah semuanya sekarang untuk kasus patologi, untuk kasus radiologi, dan juga untuk kasus yang lainnya itu sudah banyak menggunakan citra digital atau equipment daripada medis itu sudah menggunakan equipment yang menghasilkan digital image untuk dijadikan oleh seorang expert dokter sebagai bahan untuk mempertimbangkan, mendiagnosis dari pasien ini apakah sakitnya itu kategori sedang, ringan, ataupun parah, kan seperti itu ya. Nah, jadi pemanfaatan teknologi citra ini sungguh sangat memudahkan kehidupan manusia, karena untuk hal-hal yang sangat urgen seperti citra digital yang di bidang kedokteran tadi, itu sudah sangat urgen kedudukannya, karena dari bahan image tersebut dokter dapat mendiagnosis dan mengklasifikasikan apakah pasien ini level A, B, atau C. Nah, itu untuk kasus kedokteran. karena kedokteran ini adalah masalah hidup dan mati manusia, maka image processing di dalam kedokteran, implementasi di kedokteran dan juga AI di dalam dunia kedokteran itu sangatlah menjadi sesuatu yang luar biasa improve-nya di dunia ini. Oleh sebab itu, apabila kita lihat di jurnal-jurnal internasional dan juga pada permasalahan yang ada di statistik WHO ya, kita dapat melihat begitu banyak cancer atau banyak kasus yang diderita oleh manusia untuk berbagai macam penyakit itu improve step by step dengan mengimplementasikan early detection ya. Jadi early detection adalah sesuatu yang sangat mungkin kita bangun dengan AI. Karena apa? Karena deteksi awal itu sebenarnya dapat dilihat oleh kalau tidak dideteksi secara dini, maka penyakit itu akan semakin parah ya. Apabila dideteksi dengan early detection, maka kita dapat mencegah. Nah, dengan adanya AI, alat-alat yang dapat memudahkan tersebut dibuat sangat mudah di bidang membantu bidang kedokteran dalam melihat keabnormalan itu secara cepat, sehingga perkembangannya sangat luar biasa ya di dalam biomedical engineering ya untuk saat ini. Nah, untuk kasus lain selain di biomedical implementation, image processing itu juga digunakan di security ya. Security adalah hal yang sangat mungkin dibuat apabila video atau image dari surveillance system ataupun dari kamera yang untuk mendeteksi iris ya, dan juga untuk melihat wajah gitu ya, kamera ya, itu berada di mana-mana. Dunia ini penuh dengan apabila kita masuk ke luar negara lain itu kan ada kamera yang akan mendeteksi, sehingga apa saja kejahatan yang dibuat oleh seseorang itu dapat diantisipasi, dia tidak bisa melarikan diri ke luar negeri kayak gitu ya. Nah, itu dapat langsung dideteksi dengan AI karena sistem kita yang untuk keluar masuk itu sudah menggunakan kamera juga. Nah, tidak manual, sehingga untuk implementasi AI pun sangat berguna di bidang security. Nah, di hal lain adalah penggunaan di informasi dari satelit ya. Kalau informasi dari satelit kita dapat melihat sesuatu kejadian atau bencana, underwater image dan lain-lain, itu juga memerlukan informasi atau manipulasi dari digital image. Nah, dengan image processing dan juga AI, maka keberadaan dari kepingan pesawat ya yang ada di bawah air dan lain-lain, nah itu dapat dilihat. Bayangkan kalau untuk mencari sebuah kepingan tidak menggunakan image dari satelit, maka coba dilayari lautan yang sebesar itu dan juga nanti malah menimbulkan bencana baru gitu ya. Di konon kita mau menyelamatkan atau mencari kebenaran suatu bencana, malah nanti menambah bencana. Nah, maka kita perlu sebuah sistem yang sangat memudahkan ya dengan seminimal-minimalnya resiko, yaitu dengan image processing. Kalau bisa seminimal kita gunakan itu dahulu. Oke, untuk bahan kali ini saya sebagai moderator, digital image processing ini ya adalah sebuah metode yang sangat bergantung kepada manipulasi dari image. Bukan manipulasi ini artinya menggunakan algoritma-algoritma tertentu dalam sebuah proses yang diperlukan untuk mengenali objek. Nah, dengan mata kuliah image processing dengan computer vision itu adalah suatu mata kuliah yang sangat related, yang tidak bisa dipisahkan ya, untuk dapat membuat sebuah sistem yang cerdas ya. Oke. Untuk deep learning sendiri tadi sudah dibahas, deep learning ini sendiri itu bisa meminimalkan penggunaan algoritma image processing. Hanya saja dengan komputer yang dimiliki haruslah berkekuatan power ya. Nah, jadi kalau komputer-komputer yang masih di bawahnya, maka lakukanlah riset mesin learning yang mana di machine learning itu memerlukan image processing agak banyak, ya, algoritma image processing agak banyak, sehingga ketika yang diinputkan ke dalam classification learner itu bukanlah sebuah image, melainkan sebuah angka-angka yang udah lebih sederhana. Kalau mahasiswa tahu, bisa dilihat ya di Google ya, apa itu image? Kalau image berdasarkan kacamata komputer, image itu adalah sebuah matrik yang besar. Ya, kalau dia resolusinya 1000 dikali 900, maka angkanya matriknya adalah matrik baris kolom. Barisnya tadi 900, kolomnya 1000 gitu ya. Nah, seperti itu. Nah, kalau menggunakan image processing, angka-angka yang tadi yang diolah oleh deep learning yang berupa 900 dikali 1000 matriks itu digunakan langsung oleh deep learning ya, itu bisa disederhanakan dulu menggunakan image processing dengan banyak algoritma yang dapat digunakan ya. Algoritma ini pun digunakan, tidak semuanya digunakan. Kalau kita belajar pengolahan citra digital ya, nah itu algoritma yang ada tidak semata-mata tanpa pertimbangan kita gunakan, tapi kita harus tetap menggunakan based on knowledge, seperti pre-processing. Seandainya image yang kita punya yang untuk kita gunakan untuk pembelajaran itu tidaklah perlu di enhance, udah bagus kualitasnya, maka pre-processing yang enhancement itu tidak diperlukan. Apa yang diperlukan? Lebih kepada segmentasi dan juga ekstraksi fitur gitu ya. Nah, namun pada dasarnya karena sekarang alat-alat ini masih terbatas dan juga yang di capture itu bukanlah sesuatu yang contoh dalam security yang difoto itulah bukanlah orang yang siap untuk di capture, terkadang adalah orang-orang yang sedang berjalan atau melihat sana sini gitu kan. Nah, itu yang di capture, maka tetaplah sering ya pada riset itu digunakan pre-processing sebagai tahap yang harus dipakai. Nah, untuk setelah itu, setelah pre-processing, bagaimana image itu dapat digunakan ke machine learning itu adalah dengan melihat ciri-cirinya. Objek ini yang mau kita lihat adalah objek misal ya, kategori contoh apa ya, manggis misalnya ya, manggis yang kategori A atau level A ya, yang paling bagus super, satu lagi manggis yang masih kualitinya kurang bagus. Itu bedanya dapat dilihat dari volumenya misalnya ya, atau bentuknya. Nah, ini bentuknya agak penyot, kalau ini bulat bagus gitu ya. Dan juga dapat dilihat dari bagian kepalanya mungkin ya, itu kelihatan seperti mahkota. Nah, yang satu lagi bisa jadi tidak seperti mahkota atau tidak sempurna gitu. Kita jadikan itu sebagai ciri-ciri. Nah, kalau itu sudah jadi ciri-ciri, maka nanti algoritma yang kita gunakan itu untuk ekstraksi fitur depend on apa kasus yang mau diekstrak. Kalau contoh seperti tadi, kita mau mengekstrak bentuk ya, bahwa bentuk yang kualitasnya A dengan kualitasnya B itu secara bentuk berbeda, maka kita dapat menggunakan algoritma ekstraksi fitur bentuk. Contohnya, salah satunya adalah menggunakan hue moment invariant gitu ya, atau HOG gitu ya, histogram of gradient gitu ya, dan juga banyak lagi yang lain. Atau malah teksturnya dari manggis yang kualitasnya bagus ke manggis yang kualitasnya kurang bagus, itu dari segi tekstur manggis yang bagus itu dia sangat smooth, kalau yang tidak bagus itu banyak bercak-bercak. Jadi kita dapat membedakan dari tekstur, maka untuk kualitas itu kita bedakan dengan tekstur menggunakan metodenya gray level concurrent matrix dan juga banyak lagi yang lain, Harlow flat. Nah, oke. Now kita akan fokus kepada enhancement ya. Untuk enhancement, kita akan melihat penjabaran dari Ibu Dr. Siti Nuraini, bagaimana proses enhancement sebelum kita dapat menggunakan ciri-ciri yang kita input ke dalam machine learning ya, yang menjadikan nanti dia matrik yang sangat kecil, bisa jadi matriknya itu Y-nya menjadi 16 kalau untuk GLCM ya, sedangkan barisnya itu adalah sebanyak citra. Nah, beda dengan yang kasus deep learning. Nah, ini menjadi matriknya lebih sederhana. Oke, sekarang Ibu Siti Nuraini ya sudah mempersiapkan ya, nanti beliau akan masuk di sesi tanya jawab ya, karena ada workshop yang sedang dilakukan. Maka ini kita fokus pembicaraan dulu kepada lecture hari ini ya, kita fokus kepada image enhancement terlebih dahulu. Ada beberapa kategori image enhancement algorithm yang dapat digunakan yang akan dijelaskan oleh Dr. Siti Nuraini, Dr. Siti Nurul Akmariah Muhammad Kanafiyah. Silakan Mbak Wikan, play.
What is image enhancement? So image enhancement is the process of making images more useful, such as making images more visually appealing, bringing out specific features, removing noise from images, and highlighting interesting details in images. And also you can see here from the input image here, from this input image or original image, this is also, we call it as original image. We apply enhancement techniques. Which is the technique is from spatial domain or frequency domain, or also combination method from the spatial and frequency domains technique is applying to the image. Okay, applying to the original image to obtain a better image for analysis by a human or machine. Okay. Okay, as I said in previous slide, the purpose of image enhancement technique is normally for noise removal and contrast adjustment, whether in grayscale or color image enhancement. This is the example lah. This is the example of grayscale image enhancement techniques. And also figure number 1 is for noise removal for Air Force aeroplane, and figure number 2 is for contrast adjustment to the building images. Okay, this is for grayscale or one layer image lah. Grayscale is one layer. Okay. Okay, inshallah next slide I will show you the application in color image enhancement methods. Okay. Okay, for this image enhancement techniques, the existing techniques of image can be classified into three categories. First is spatial domain enhancement. Second is frequency domain enhancement, and also the lastly is combination methods, as I said in previous slide. These techniques, okay, spatial domain, frequency domain, and combination methods. So the existing technique of image can be classified into three categories lah. Spatial domain enhancement, frequency domain enhancement, and also combination methods. So for the spatial domain enhancement technique it manipulates the pixel of an image directly, and it is operating on pixel, and this process is happens in the image coordinate system, also known as the spatial domain. And for the frequency domain, frequency domain enhancement is the techniques that transform an image from the spatial domain to the frequency domain, and frequency domain is operating on the frequency transform of image. So in this process, mathematical transformation such as Fourier transform are used, and the image can be modified by manipulating its frequency component. And lastly is combination methods. Method is there are some enhancement based on the various combinations of methods from the first two categories, namely spatial and frequency domain enhancement technique are combined together. So we will go in detail about spatial domain and frequency domain in the next subchapter. Okay, for the frequency domain, okay, as indicated previously, the term spatial domain refer to the pixel composing an image. So spatial domain methods are the procedures that operate directly on these pixels. So spatial domain process will be denoted by the expression gxy equal to tfx, where the fxy is input image, g is the process, fxy is the input image, g is the process image, and t is an operator. Okay, t is an operator of f, operator of original image lah. F is the original image or input image lah. And then t can operate on a set of input image. T can operate on a set of input images, and this spatial domain these spatial domain operations can have three different forms. First, one is the point processing. The other one is histogram processing, and the third one is neighborhood processing. So for digital, for point processing, or we call it as point operation, change each pixel in a way that depends upon its own value, but not upon where it is in the image, nor upon the value of other pixel. So this is in contrast to neighborhood operation, which calculate new pixel values based on the values of pixel nearby. So in this image, digital negative method is used for point processing techniques. So digital negative simply means that inverting the grayscale. It's inverting the gray scale or gray level lah, which means that black in the original image will be convert to white pixel value in digital negative and vice versa. Okay. So here let's see the coding. Let us see the coding. Kejap. I will show you the coding. Okay, for digital negative, okay, for the first we need to create the editor. Okay, for the first you need to create the editor. Okay. Okay, this is close all, clear all. So you must know what is the function of close all and clear all to clear the image after you run the second okay. So this is the of how to read the image. Okay. So for this part, we use M2, M3, and M0. So for M2 is dots, M3 is BMP, and M0 is the address location where we save the image. And also we call it by using IMRead Z. So we arrange the M0, M2, M1, M2, and M3 like this based on Z, variable Z. And then A equal to IMRead Z. M0 is address or location where we save the image. And then M1 is the image is in number 1 image. M2 is dot and M3 is BMP. So we read the image from the okay, we read the image from this address location. So number 1, image number 1. So we run it based on this number 1. So we save it in this okay. Okay, we just run it. Okay, this image is displayed in original image because we call original image, and then we convert RGB to gray. Here we convert RGB to gray. So we just evaluate selection only because we already run from the whole of this editor. So this is original grayscale image. And then next, we want to use the digital negative, right? So we just run this coding. So where I took this coding, so you just find from the help MATLAB. Okay, this is the coding of the digital negative methods because we complement you just complement the image, the grayscale image, then you get the okay, this is image gray from the original image gray. So negative image, just use the IM complement. Then we take the image gray here, image gray, and then we show the figure. So you just show the figure here like this, and then it's complement from the original image. You can see this. This is original grayscale image, and then you just complement it because this method is digital negative, right? So the white pixel value is going to be black, and the grayscale, the gray is going to be complement they complement each other. Okay. Then also you can use these methods. Okay. This method is similar to this IM complement. So despite, because in MATLAB, in the grayscale image, we have 0 to 255, 0 to 255. So you just use this maximum 255 minus image gray. 255 minus image gray is original image gray from this grayscale image, and then you just show the figures lah. You can get like this. Also, this is the similar with this one. IM complement, or you also can use this coding. Okay, this is for digital negative methods. So image means that replacing all pixel values. Replacing all pixel values present in the image with its logarithmic values, and log transformation is used for image enhancement as it expand dark pixel of the image as compared to high pixel values. So it depends on C values. It depends on C values that we use in the algorithms. So you can try it by using MATLAB lah. You can try it by using MATLAB. And this is also the original image. This is the grayscale image. And this is the color or RGB image from original RGB image. And then use the log transformation. So the image become lighter lah. Lighter than the original one. Okay. Okay, next is what? Power law transformation operation. Okay, power law transformation operation is performed on an image to enhance it for different types of display device. So this image transformation is required because different display device have different gamma values. So here methods in MATWork or helps, and you just run it, power law transformation. Okay, you just run, just evaluate selection because you have already run the whole coding. So let's say here you just put the gamma. Okay, we try to test to put the 345 gamma. And then the image show like this. Okay, this is the original grayscale image. And then this is the gamma, 3 gamma based on the gamma, 3 gamma values. And this is 4, and also this is gamma 5. So the image become like this lah. So it depends on your application. It depends on your application, and also it depends which of the gamma that's suitable to your image. Okay. Okay, this is the coding lah for power law transformation. Okay. And then this is the graphical representation. And then a graph is plot, is a plot by the number. Plot by the number of pixel for each tonal value or intensity values from the image. So remember that the image, the grayscale image have 0 to 255, right? And the grayscale image have one layer. So this image is only have one layer only for histogram stretching, just for grayscale image. Okay, 0 to 255. If you can see 0 to 255, and here the histogram is start from 0 to 255. The 0 is represent as black lah in the image, and 0 here is represent as black. Black until gray, and 255 is white. 255 is white pixel value. So here you can see that the black pixel value here, there have majority, the majority one in the graph or histogram is black pixel value, blacks to gray lah. So this is going to be dark image, right? This is dark image. Then after we apply histogram stretching, the image is going to be brighter lah. To be brighter. And then the black pixel value is shift to the 255. Kan? They don't have black pixel value. So minor just only minority in the black pixel value, because we implement histogram stretching to for the image to become lighter, okay, or brightness. Okay, for this coding of histogram equalization, okay, I will show you this coding that you need to use for this, that you can use lah for this MATLAB, is because this is histogram stretching. So we have a lot of histogram stretching here. We have contrast stretching, also we have histogram equalization, intensity adjustment, and also contrast limited adaptive histogram. So this is the, so we implement to grayscale image because this image is going to be grayscale image, original grayscale image. So the image is going to be like this. This infected, or we call it as parasite. This is the parasite. I forgot to inform you that this is the malaria image. So this is the parasite, and this is the cell. This is the red blood cell, and this is the infected red blood cell that infected by the parasite. Okay, by the malaria parasite lah. Okay, this I am just, we implement 0.2 and 0.6 lah to adjust the intensity. So image is become like this. And then after we implement the histogram equalization, the image is become like this. And also after we implement adaptive histogram equalization, the image is going to be like this from the original image. This is original image, and this is the adaptive histogram equalization. So this coding you can find in the from MATLAB Help or MATwork. Okay. when a function is applied to the interested pixel and its neighbor. So the idea is to move a mask. The idea is to move a mask which is normally an odd length rectangle over a given image. Okay, this figure shows the mask 3 times 3 multiplied by 3 neighborhood about a point xy in an image. This is 3 times 3 and for this, the spatial domain enhancement operation can be reduced to the form gxy equal to t fxy, where fxy is the input image, this is the input image, and gxy is the process image, and t is the operator such as adaptive state, histogram equalization, histag, as I show you just now. And among of types of neighborhood processing in image enhancement methods are smoothing filter and sharpening filter. For smoothing filter, such as averaging filter or Gaussian filter, and for sharpening filter, such as high pass filter, low pass filter, or band pass filter lah. Okay, let us see the coding from the MATLAB for averaging filter, Gaussian filter, and also the other filter lah. Okay, for this coding for the MATLAB, from the MATLAB, okay, integral image and then integral kernel, so you must averaging filter image. So you can see that this original image have a noise, right? From the background, they have a small noise or blurring image. And after we implement averaging filter, the background is become smooth. Okay. Then you can adjust by using this windowing size. So if 3 times 3, you can adjust 3 times 3, 9. So you have 9 pixel value here. And then you run it, then you can see the averaging filter. Your image is become like this. So it's not, don't have any effect kan, ada effect sikit-sikit je lah, this part. And also you can adjust 5 times 5, 25 lah, here, 25. And also here, you use medium filter. By using 7 times 7 windowing size. So this is after implement medium filter from the original grayscale. So this is the original and this is medium filter. So image become better, the background of the image become better from the original grayscale image. So you can adjust lah, you can adjust 7 times 7 or 3 times 3 in this part. And also implement salt and pepper from this medium filter. And this is the Gaussian. Okay, this is the Gaussian. And this is original image. So you can see that which one is better. Original grayscale from the original grayscale. This is the Gaussian image. After you apply Gaussian, then this is after you apply medium filter. And this part is after you apply averaging filter. So it's up to your, actually it's up to your image, which one is better. Maybe your image is better by using Gaussian filter, and maybe your image is better by using medium filter, and also maybe your image is better by using averaging filter. It's up to your image actually. Okay, you must try and error lah from this coding or from these methods, all these methods. Okay, do the pre-processing and then applying Fourier transform and filter function inverse Fourier transform, and lastly post-processing to obtain the image, the enhanced image, to obtain the enhanced image. So there are many steps for the frequency domain methods. You must going through to pre-processing Fourier transfer, filter function, inverse Fourier transform, post-processing, and you can get, after post-processing, you can get the enhanced image. Okay. And then for the enhancement methods, this part we will explain a part of image enhancement methods. So first is contrast stretching. Contrast stretching is a process that transforms the intensity values of an image to a new range, usually 0 to 255. Okay, to a new range. This process is to transform the intensity values of an image to a new range, usually 0 to 255. Okay, for 8-bit images. Okay, the goal is to increase the contrast between the darkest or brightest pixels, and while preserving the relative difference among the intermediate values. So the contrast stretching is produce higher contrast than the original image by darkening the levels below M in the original image, darkening the level below M. This is M, and then darkening the level below M in the original image, and brightening the level above M in the original image. So contrast stretching is a simple image enhancement technique that improve the contrast in an image by stretching the range of intensity values. Okay, so the second one is medium filter and averaging filter, which apply to noise reduction. I have showed you the coding for medium filter and also for averaging filter just now. And the medium filter is a non-linear lah. Medium filter is a non-linear method used to remove the noise from the images, and it is widely used as it is very effective at removing noise while preserving age. And this is the calculation using medium filter. So the mass here is, you can see here, the mass is 3 times 3. 3, 1, 2, 3. 3 times 1, 2, 3. The mass is 3 times 3 windowing size. We call it as windowing size. So this part is 1 to 4, 1 to 6, 1 to 7, 1 to 0, 1, 5, 0, 1 to 5, and also 1, 1, 5, 1, 1, 9, 1, 2, 3. Okay, so we rearrange by follow the sequence start from small to large number in this 3 times 3 windowing size. Okay, and the number in the middle, 150, the number in the middle will be replaced with a new number, will be replaced in a new number from the medium value found. So you can see here, this is the new, this is original. We take from this, and then this is the new one, new image. After we implement median value, median filter lah, after we implement the median filter. So how to implement median filter? So we rearrange by follow the sequence. Start from small value, small intensity value, 115, 119, 120, 120. We use this, just only this pixel value 3 times 3 windowing size. So the small intensity value is 115, and then the second small intensity value is 119, and then the third small intensity value is 120, and next is 123, the small, and 124, and also 125, next 126, 127, and also 150. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 3 times 3 lah. 3 times 3. And then we rearrange to this 3 times 3 pixel value. Start from 115, 119, 120, 123, 124, 125, 126, 127, and 150. So your new intensity pixel value is 124. 124, because we need to find the median value. The median value is 124 from this image. So the image, the new image is going to be 124. Then the pixel value is moved to the next windowing size. So the next windowing size is this lah. Just now this one, right? Okay, just now for the first is this one. Okay, for the first actually this one. Okay, the pixel value will change for this part, and then this part, and then the pixel value will change this part, and then the masking is moved to the next, and then we change this part, and also go to the next until finish the location or coordinates of the image. So if your image have 500 times 600, so your image will move to the next and next and next to change the pixel value based on the median filter. So the image become the new one lah, after implement median filter until finish this part. Okay. Okay, averaging filter. this averaging filter. Okay, averaging filter is simple in that we take basically the mean of neighboring pixel, and this pixel is used for removing noise, and it basically blurs our image. So this is the averaging filter. The mask used for this averaging filter is 3 times 3. Okay, we use 3 times 3 windowing size. Okay, for example, 1 to 4, 1 to 6, 1 to 7. We take from this image. One to 0, 1 to 4, 1 to 6, 1 to 7, 1 to 0, 1, 5, 0, 1, 5, 1 to 5, 1, 1, 5, 1, 1, 9, and 1, 2, 3. So you must add all the pixel values because this is averaging. Averaging filter is like mean filter. So you must find the mean value. So you must add all the pixel values and divide it by 9 because 3 times 3 is 9, right? So because we use 3 times 3 windowing size, so you must multiply by 8, divide by 9. So, but if we use 5 times 5 windowing size, so you must divide by 25, kan? So if you implement 7 times 7 windowing size, so you must divide by 49. And then if implement 5 times 5 windowing size, your image become larger lah. Your mask become larger lah. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But in this part, we try to implement 3 times 3 because it's easy to us to divide by 9 only. And for this question, you just add 1 to 4, add 1 to 6, add 1 to 7, plus 1 to 0, 1 to 5, 150, 1 to 5, plus 115, plus 119, plus 1 to 3, divide by 9. And then you can get 1 to 5.4. And then your pixel value is actually 1 to 5 lah, pixel value. So the pixel value here is changed to 150 pixel value, changed to 1 to 5 pixel value. Okay. Okay, this part is going to change 1 to 5. Then after that, you must move to the next by using this 3 times 3 masking size. Move to the next, and then you change this pixel value also based on the adding averaging filter, adding 9 pixel value and divide by 9, and then you can get the new pixel here. Okay.
Oke ya. Oke, baik. Alhamdulillah ya untuk presentation dari Dr. Siti Nurul Akmaria sudah menjelaskan about algorithm untuk enhancement based on histogram dan juga beberapa filter yang dapat digunakan dalam proses enhancement dalam image processing ya. Oke. After image enhancement ini nanti kita akan continue kepada augmentasi seperti yang dipakai oleh Prof. Siti Nur Aini tadi, dan juga nanti follow kepada segmentation ya, nanti akan kita bahas segmentation. Nah, nanti setelah segmentation barulah kita extract features menggunakan algoritma lagi gitu ya. Jadi untuk tadi contoh-contoh image enhancement sudah diperlihatkan oleh Dr. Siti Nurul Akmaria, dan juga nanti next kita akan mencobakan kepada minggu depan ya, kita akan coba beberapa coding dan nanti mahasiswa bawa laptop sendiri untuk kita dapat mencobakan sendiri. Nanti akan kita lihat ada error atau tidak, dan kalau ada error nanti kita akan solving bersama-sama sehingga nanti kita dapat menggunakan algoritma enhancement ini untuk kasus riset masing-masing. Oke, now untuk tanya jawab dipersilahkan kepada mahasiswa yang ingin bertanya. Oke. Kalau mau bertanya silakan raise hand, boleh ya. Oke. Oke. Dr. Siti Nurul Akmaria, boleh jelaskan untuk research biasanya digunakan algoritma yang mana yang sering digunakan dalam riset image processing dan AI? Silakan Dr. Nurul.
Assalamualaikum warahmatullahi wabarakatuh.
Yeah.
Sorry, saya agak agak busy sikit hari ni. So macam mana recorded video tadi, okey? Lama sangat recorded video tu. Okey, untuk pertanyaan Dr. Yesi tadi berkenaan dengan image enhancement. Sebenarnya image enhancement ni dia bergantung kepada sesuatu image. Apa image yang kita gunakan. So saya tak boleh nak cakap sama ada medium filter is the best methods lah untuk semua image, ataupun averaging filter is the best method. Kita boleh nak bagi tahu macam tu sebab the best method adalah depends on the image yang akan digunakan, sebab kita tak tahu kesesuaian of the methods tu kepada image tersebut. So dia depends ataupun bergantung kepada sesuatu image tersebut. Okay.
Okey, jadi macam tu ya. Jadi depend on kepada image yang kita gunakan juga, apa yang mau kita implement untuk enhancement-nya ya, Dr. Nurul ya?
Ya, betul.
Okey, sama ada apakah pakai yang enhancement by histogram atau pakai filter macam tu ya?
Ya. Sebab kita biasanya dalam image enhancement ni dia ada contrast enhancement dan juga noise filtering. So kita perlu kebiasaannya kita akan gunakan kedua-dua lah untuk remove the noise. After we remove the noise, kita perlukan untuk enhance dia punya the region of interest ataupun keseluruhan image tersebut. Jadi daripada situlah kita dapat tahu sama ada, that's why kita perlu try and error. Try. Sentiasa try untuk setiap coding ataupun untuk setiap algoritma yang digunakan tu lah, sama ada algoritma yang median, averaging filter ataupun sebarang method yang kita ataupun sebarang method yang kita buat sendiri untuk filtering dan juga contrast enhancement. Sebenarnya kedua-dua itu adalah penting lah untuk sesuatu image tu.
Okey, Dr. Nurul, saya nak tanya lagi nih, mungkin mahasiswa ada bertanya yang macam ni. Apakah ada efek yang diberikan oleh enhancement kepada next step? Misalnya next step kita nak segmentation. Apa efek kepada segmentation bila kita menggunakan enhancement? Boleh di-explain Dr. Nurul?
Okey, efek kepada segmentation ya. Efek kepada segmentation maksud Dr. Yesi.
Ya, betul.
Okey, sebenarnya
ya, Dr.
Ya?
Ya, betul.
Okey, sebenarnya efek kepada segmentation dia sebenarnya penting kepada the next feature extraction sebenarnya. Sebab enhancement ni dia akan untuk dia perlukan untuk proses image, untuk proses the image untuk dapatkan the feature targeted tu, untuk dapatkan feature targeted, and then memudahkan proses segmentation sebab kita dah remove dia punya noise, the background noise ataupun di sekeliling of the region of interest yang kita nak dapatkan daripada segmentation tu. And then selepas daripada kita remove the noise, segmentation akan lebih mudah untuk dilaksanakan dan juga seterusnya membantu juga untuk mendapatkan feature yang lebih baik. So dia saling bergantunglah each other. Enhancement dan segmentation bergantung kepada enhancement dan juga feature extraction bergantung kepada segmentation dan juga enhancement. Okay.
Oke, maknanya nanti memang di step tersebut sangat diperlukan untuk result yang terbaik ya, untuk classification di end of this image processing yang tadi disebutkan sampai ekstraksi fitur, itu adalah nanti classification ya Dr. Nurul ya.
Iya.
Oke, baik. Terima kasih kepada Dr. Nurul atas insight yang sudah diberikan dalam part image processing. Ya, semoga nanti in the next step kita dapat mengupas tentang segmentation-nya ya Dr. Nurul ya. Untuk the next class kita boleh nanti membahas tentang secara fokus pada segmentation ya Dr. Nurul.
Iya, insyaallah.
Oke, baik ya. Karena waktu yang memisahkan kita ini ya, waktunya sudah habis. Maka untuk sesi untuk kuliah series ini kita cukupkan. Terima kasih kepada Dr. Siti Nurul Akmaliyah yang sudah memberikan penjabaran dari Malaysia ya, University Malaysia Perlis. Dan tadi Ibu Prof. Siti Nuraini adalah dari UITM Penang ya. Jadi alhamdulillah kita sudah ada 2 knowledge yang kita sudah improve dalam research image processing dan juga recognition, object recognition, yaitu menggunakan deep learning tadi ya. Oke, terima kasih sekali untuk sesi kali ini ya. Kita close untuk next step kita akan melanjutkan dengan beberapa topik yang berbeda. Untuk selanjutnya saya serahkan kepada MC yaitu Mariza Intan. Kepada Mariza Intan dipersilakan. Terima kasih Dr. Nurul.
Terima kasih.
Thank you, Dr. Yesi Jusman and Associate Professor Dr. Slamet Riyadi. Ladies and gentlemen, finally we arrive at the end of the webinar. Thank you for your attention and thank you for all your participation in this webinar. Allow me to conclude this webinar by reciting Hamdalah together. Alhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Oke. See you
Terima
in the next
kasih
series.
Dr. Noni, Dr. Nurul.
Iya, terima kasih Pak Slamet Riyadi. Saya close dulu. Assalamualaikum. Terima kasih Dr. Noni.
Yesi, terima kasih.
Nurul.